Hi and welcome to today's video. We're going to do work on the project today. We're going to add an event to our simulator in Compix, and the event we're going to add will be an index entry or many index entries that we're going to add to some peers in the system. So looking at our system diagram here, you can see that I'll just select the pen. You can see we have our simulation up here, and what we want to do is we want to have an index event, an add index event. Let's call it add index. This is not a real pen I'm using today. And we would like it to go in here to our simulation. And it will be picked up by our peer-to-peer simulator, which will send the event over the simulator port to this search simulator component. So what we need to do is we need to define the event here. We need to then send it to the peer-to-peer simulator, and in that case we do that by defining it inside a stochastic process, which we'll look at now. Let's see. If we go to our project. So we can start at our main point, which is where we come in, and we can navigate from there. So you can see in our main we're using scenario 1 at the moment. You can see I've already started on this, in fact. So let's just maximize the screen here. So here's scenario 1. Just to remind you, we have a process, a stochastic process, which is raising a single event, which is a peer joining the system. And then we have a second stochastic process, process 2, which raises 5 events of peers joining the system. So we have 6 peers joining the system. We can see here actually that process 1 starts. We also have to have our stochastic process start. And then process 2, adding the 5 peers, it will start after termination of process 1 with a delay of 2 seconds, 2000 milliseconds. So I've already added a process 3, which is a stochastic process number 3, which will raise 100 events of adding an index entry. And that process will start after we've added the last 5 peers. So let's start by looking at how I did that. So raising 100 events is fine. What we're doing is we have this operation which is called add index entry, and it takes a parameter which is a uniform big integer in the range 0 to 2 to the power 13. So here's our operation. It's a static method, you can see. And what I did was I basically took the template of the peer join method, and I copied it. And it's in fact it's a method returning an operation object of taking a single parameter. So the 1 indicates that the single parameter, and here it's templated, so the parameter is a big integer. We can also add an additional parameter here. So when I started out writing this, I thought, well, the index entry I'll add in here in scenario 1, the actual value of it, and you can see I'm passing an empty string here, but then I changed my mind. So we're actually deciding on the entry inside the simulator. So in this case, all it's doing is it's generating, our simulator is going to generate a big integer id, which will be uniformly random within the range 0 to 2 to the power 13. That will get passed in as a parameter here, and it will create an add index entry object, which is an event. So we can navigate to that now and see it. We have add index entry event. It has an ID. The ID in this case will be the ID of the peer that we're going to add the index entry to. Remember, we've created 6 peers now at this stage, so this add index entry event should get sent to a uniform random peer from amongst those 6 peers. The text for the actual in this case it's going to be an index entry, we haven't filled in. We'll fill that in the simulator. Now let's go back. So at this stage we have this add index entry, add IE, we'll call it, an event, which is very messy. And it's getting sent down here it gets written to a file, which peer-to-peer simulator reads up, and then it sends it over a simulator port that we define. So we now need to look at the port where these events arrive in from the peer-to-peer simulator to the search simulator. Let's jump back here. Okay. So we can do that by looking at the search simulator here and looking at the port. We can see there's a port on it here called the simulator port. And if we want to assure ourselves that the simulator port exists and it gets sent from the peer-to-peer simulator, we can look for the search simulation main component. So in this search simulation main component, you can see that it's a standard compix application. So search simulation main, as I mentioned before in the lecture, it gets launched as a JVM process by the actual scenario, and you can see here that inside it you have a scheduler. So a scheduler, we have a simulator scheduler. We have one worker thread created in compix. If you want to speed it up, you can increase that number if you have many cores. And we can see here that for our peer-to-peer simulator component, we set the peer-to-peer port type to be simulator port. So that means that this peer-to-peer simulator component has a simulator port, and over that simulator port it's going to send events to the search simulator. So I've already added our event to that port. Remember, in compix, if you want to send an event between two components, you have to send that event via port. Think of your port as being your interface, and the events being equivalent of methods defined on that interface. So in this case, we want our event to go into the search simulator. Our peer join event is already doing that, so I'm just copying that and having exact same structure, add index entry as a positive event going in through the simulator port. So now if we go back to our search simulator here, we can see that the peer join event was already coming in. So we had a handle peer join event for that. And the peer join event has to be subscribed to on the simulator port. Similarly, we have to do the same with our handle add index entry. So if we go to our add index entry, we can see our handler. Now I just basically cut and paste this from the handle peer join. And you can see in handle peer join here that what it does is it gets an event which comes in, which gives an ID to the node. So the ID was a uniform random ID between 0 and 2 to the power of 13. And it looks up that ID on this thing called ring nodes. I think that was called all nodes actually, and I just changed the name to it. Now all nodes itself is a consistent hash table. So as you know, in consistent hash tables, if you look up an ID, you should get the responsible node. So the idea behind this ring nodes object is that given a random ID in the ID space, we'll get back the actual peer or component responsible for that range of the space. So in this case for peer join, what we're basically trying to look at is say, well, if I generate a random ID and a node already has that random ID, then that's not very good. So what I'll do is I'll just pick in this case it would pick an ID which is one higher in size. And then if no other peer has that particular ID, then it can create and start the peer. So in our case, we want to add an index entry to a uniform random peer. So we'll just, given the ID, the random uniform ID coming from the event, we'll just get the successor ID for that peer from the consistent hash table. So in this case, when we have the successor ID, we can then look it up in this, we have a hash map of peers, you can see here. So this peers is when a peer is added, we insert the ID for that peer and the actual component object. So now in the other case, we're actually looking up a peer. We have its ID, we get it from the consistent hash table, and using that we can actually get back the peer object. So now that we have the peer object and we have our add index entry event, we can send it to the peer. We can send to the peer because we've defined an index port over which we'll send the event. So this particular event, which we want to send to the search peer, if we go to our search peer, we have a look here. So we want to send this event to our search peer here. So let's write some numbers here. The event goes firstly to the peer-to-peer simulator. It's number 1 here. And then we're sending it to the search simulator number 2. And now it's going to go to the search peer number 3. And finally it'll end up at this search component number 4. So the search peer component, it doesn't have any port defined on it. So it has a network port and it has a timer port. So if we look at it, you can see that I defined a port over which we can send the event, and the port is called index port. In fact, we do have an existing port already called the web port as well. I've forgotten about that. So we have a network port, timer port, web port. Those ports are part of the compix framework, so I don't want to change them. So I'm adding a new port, the index port, and again, it's positive added index entry is the type of event that's coming in, the same as we have for the simulator. And that port will now receive the event. And in our case, what we would like to do is we'd like to just forward that event from the search peer into the search component. We'd like to get that in there. Now, this particular component, the search peer, doesn't need to do anything with the event. So we don't need to have a handler. We can get away with, in fact, just connecting. And this is what we're doing here. We connect the index port on the search peer to the index port defined on the search component itself. So that means all the events coming in and out of the index port at the search peer level will get sent, forwarded to the search peer, and forward in and forward out of the search component, sorry. So let's look at the search component now. You can see we defined the index port on it, and we need to have a handler for that. In fact, we need to have a handler for the add index entry. And we see here we have a handler, we've subscribed it on the port, and the event will come in here.